Okay, so let me go to the page. Okay, so just a quick recap. Quick recap is we are discussing future oath method, and the mode of solution is different from present oath method. And secondly, look at question number 6 and 7. We have already discussed that the two formulas that you see in these two numerical 6 and 7 are the two formulas you would be using for solving any questions on future oath method. The first formula, let me bring in the highlighter. The first formula is this one, and this is nothing but the compound interest formula, just that we have used different notations for that. Instead of A, we have written FW. Instead of P, that is principal, we have written PW. So same compound interest formula, no difference. And the second formula is this one. FW is equal to PW times 1 plus R whole to the power T minus 1 whole divided by R. And this is another formula you would be using. And when to use which formula? I had told you in previous class. Again, repeating the same. The first formula, that is this formula, you should use when you want to find the future oath of a single amount. Like in this case, in this question, you'll find rupees 2000 is invested this year. That means a single 2000 is invested and you are required to find out its future oath after 5 years. So for that kind of numericals, wherein, as I said, you need to find out the future oath of a single amount, then you should use this formula. And this formula is for annuities. Hope you remember annuities. What is an annuity example? You'll find in this question, as it says, rupees 2000 will be invested each year for the next 5 years. So that what do you understand from this question? That not a single 2000 rupees, rather a series of 2000 rupees spanning over a period of 5 years is being invested. So this is a case of annuity, wherein the same amount gets repeated over a number of time, number of period, be it revenue or income or be it cost or expenditure, whatever. If you want to find out the future oath of an annuity, you must use this formula. Please, you will have to remember this formula. There is no other way that you can solve. So remember this, FW is equal to PW times 1 plus R whole to the power T minus 1 whole divided by R. And we have discussed two numericals. Another thing you need to remember, so for a single projects are concerned, you must apply these rules. FW greater than 0 accept, less than 0 reject, and FW equal to 0 depends on the investor. So compute FW using the two formulas I just talked about. Then at the end, look at the value, what value you've got. If it is greater than 0, you say yes, this according to the question. As per the question, answer in positive. And if you find the answer, that is the FW value is less than 0, then you answer in negative, means reject. You should be rejecting the project. And I hope you have understood these two numericals. Question number 8 and 9 we have already discussed. More or less they're same. Only difference is in question number 8 you find the returns are different. In 3 years, 15,500, 40,600, 70,600. So there is no scope of applying the second formula. So only first formula you can use and find the answer. And it was 9187 positive. So as per the decision rule, you should accept this one. And the next question, deliberately returns have been equated for all the years, all the 3 years. So because the students can apply the second formula as well. So you see the second formula has been used for 35,000. times 1 plus 12% whole to the power 3 minus 1 whole divided by 12%. And for 90,000, since it is still a single amount, the first formula has been used. That is 1 plus r whole to the power t. So, and looking at the value, you find it to be negative minus 8360, and same as per the discharge rule, you should reject this project because the FW has a negative value. Okay. Now moving next. So till this I had discussed. Now I plan to finish off a future oath today. So the next question, you find straight away a solution. I'll show you the question. I don't remember whether I've said this or not. The same question that we have solved under present oath method, the same question can be solved using future oath method. So that is why, just to save time, I had given the same questions to the students to solve. Let me show which question I'm talking about. Here it is. This question, right? You remember this question we had solved using present oath method, and the same question can be solved using future oath method. Question was, let us remember the question so that we can go to the solution. Question is time and cash flows. Time starts with 0, the corresponding cash flow is in negative, subsequent values are positive till 7 years. What do you understand from this question? You are already familiar. The project requires an initial investment of 90,000 rupees. The project is expected to give a return of 15,000 rupees in each of the next 7 years. And the rate of interest must be noted. Rate of interest is 13% compounded annually. And the question will be, should this project be accepted based on, here it is PW, but we are considering FW, because same question we are going to solve using future oath method. So remember the data, 90,000 is the investment, initial investment, 50,000 is the return for consecutive 7 years, rate of interest is 13%, and method to be used is future oath method. Let me show you the solution. And any question if you want to ask, you can ask. Okay. So look at the solution. 90,000 is the initial investment, and look at the solution. And 15,000 is the annual returns for 7 years. And you look at the solution, minus 90,000 times which formula has been used? The first formula, normal compound interest formula has been used, and very rightly so. Why? Because this is a single project. This is a single project. Sorry, not this is still a single project. I wanted to say this is a single amount. Sorry, this is a single amount, 90,000, and you are required to find out its future oath. So since it is a single amount, so normal compound interest formula should be used. 1 plus 13% whole to the power 7. Okay, plus. Now, but return, what do we found in the question? The returns are 15,000 rupees every year till next 7 years. And that's the case of annuity. It's an annuity problem, and we'll have to use the second formula. We can still use the first formula, but it will be a very lengthy process. Why to do that when we have a shortcut formula? And accordingly, the shortcut formula has been used. 50,000 times 1 plus r whole to the power t minus 1 whole divided by r. So this is how it is to be solved. And answer is minus 55,695. The answer is minus 55,695. You check it for yourself. Are you getting the same value or different values? Slightly different value is okay. If the value is entirely different, then either this is wrong, the thing that you see on your screen is wrong, or your answer is wrong. So, but slight discrepancy means this answer and your answer should be all right, no issues. So always write the conclusion this way. Since future worth is minus 55,695, which is less than 0, this project should be rejected, because that's what our decision rule says, that if FW is negative, you should reject the project. Okay. Now this is about single project. Now let us move to mutually exclusive projects. And again, you are familiar with this, because the same we discussed under present worth method. Mutually exclusive projects. That means now you are going to get questions wherein you will find more than one projects. So in case there are more than one projects, how to make a selection? How to make a selection? And you must be knowing, you must be remembering this, that there can be two different types of questions you may get. So far as mutually exclusive projects are concerned, one is revenue based, the other one is cost based. And I've already explained in detail how to identify a question which is either revenue based or cost based. I've already explained. So it is very important that you correctly identify if a question is a revenue based or a cost based question. Else you will end up applying the wrong decision rule. So that is why very important that you identify if the question you have got is a revenue based question or a cost based question. So after identifying the decision rule, look at the decision rule, which is quite similar to the decision rule that you had under present worth method. And it says for revenue based project, the project with the maximum FW amount will be selected. It was for present worth, here it was only NPW. The rest of the statement was absolutely same. Only thing different we are doing in the statement is we are writing FW instead of NPW. So for revenue based project, the project with the maximum FW amount should be selected. So look at the question. If it is a revenue based question, then find out FW for all the projects and see that which one is having the maximum value and select that one. But if it is a cost based project, the project with the minimum FW amount will be selected. That's what was exactly in case of present worth method. In present worth method also, for cost based case, the project with the minimum NPW amount should be selected. Here you have the same decision rule. Only difference is you are saying here FW instead of NPW. So for cost based projects, the project with the minimum FW amount will be selected. Correct? So looking at remembering the decision rule, let us proceed for the solution. And again, state the solution. I'll show you the question. Which question has been solved here? I'll show you this question. This question, the same question we had solved under present worth method. The same question can be solved using future worth method. And question, let us remember, then we'll go to the solution. Projects A, B, and C. 3 different projects are being considered. Any one will be selected. Initial cost in rupees is 15 lakhs, 20 lakhs, and 16 lakhs respectively. Annual returns or annual revenue. 8 lakhs, 6 lakh, and 4 lakhs. And life in years is 15 years each. Okay. So we have already discussed this question using present worth method, and we all know that this is a revenue dominated case. I have already explained. So just reiterating once again, in case you don't remember, this is a revenue dominated question. Why? Because both the components are there in this question. One is cost component, this column. The other one is revenue component, this column. And we'll have to see which column is dominating which column. and we find that this column is dominating this column. Why is it so? Because this 15 lakhs, 20 lakhs, 16 lakhs, these are all cost, but one time cost, single time cost. But these returns, look at the heading annual returns. So that shows that these are annual returns. Every year the company is expected to get 8 lakh rupees till next 15 years from A. Every year company expects to get 6 lakh rupees till next 15 years from B. Every year the company expects to get 4 lakh rupees every year for the next 15 years from C. So that shows that this is a case, or this is a question where revenue dominates the cost. So 15 lakhs one time certainly is less than 8 lakhs 15 times. 20 lakhs one time is certainly less than 6 lakhs 15 times. 16 lakh one time is certainly less than 4 lakhs 15 times. So that is why very clear that this is a revenue dominated case. I had already explained this. Now, but this, look at the rate of interest. It is 15%. It is 15% compounded annually. So let us go to the solution. Let's go to the solution. Here it is. Here it is. Okay. Okay, so look at the solution. Look at the solution. So 15 lakh rupees initial cost for A. And what you need to do, because once we decided that this is a revenue dominated case, we need to find out FW for each, for A, for B, and for C. And we'll see which one is having the maximum value of FW. So look at the solution. So 15 lakhs minus 15 lakhs times the normal compound interest formula. Why? Because 15 lakhs is a single amount. And we need to find out its future also. So 1 plus 15% whole to the power t, that is t is also 15. So 1 plus 15% whole to the power 15. Then 8 lakh plus 8 lakhs. What is 8 lakh? Annual returns. The question says the company expects to get a return of 8 lakh rupees every year till next 15 years from A. So, and that is the moment you find that, you understand that this is a case of annuity. This is an annuity problem. So accordingly, the second formula has been used, which is 1 plus R whole to the power t minus 1 whole divided by R. So just a second, hold on. Class. Okay, so second formula has been used. The second formula has been used. And very rightly, because as I said, 8 lakh rupees you are receiving every year, or you are expecting to get every year. So that is why, as I said, this is an annuity problem. So accordingly, the second formula has been used. And look at the FW value for A, that is 2 crore 58 lakhs 58,500. The FW amount you got at the end is 2 crore 58 lakhs 58,500. And looking at then B and C, another thing I have been saying this. I said the same thing about present oath method, and I'll repeat the same for future oath method. Just to save your time, because in exam, usually time remains very short. What you need to remember, since you very well know that you are going to use the same formula for B and C, what you need to do, you need to find and remember the value of these formulas first. As you can see, the value of this formula only is 8.137. 1 plus 15% whole to the power 15 its value is 8.137. You remember that so that you did not solve the formula once again for B and C. Once you remember, you can simply multiply. And the formula, the second formula, this formula, its value is 47.580. 1 plus 15% whole divided by 15 minus 1 divided by 15%. His value is 47.580. So once you can remember, you can just simply multiply for B and C. So 2 crore 58 lakh 58,500. Now that's exactly you find has been done for B and C. FW minus 20 lakh single investment, single time investment. So first formula has been used. First formula's value is 8.127. So plus 6 lakhs. Company expects to get 6 lakhs every year till next 15 years. Case of annuity. So accordingly, second formula has been used, whose value is 47.580. And its FW value is 1 crore 22 lakhs 74,000. 1 crore 22 lakhs 74,000 is the value. And C, 16 lakh rupees minus 16 lakhs times the first formula, because 16 lakh is one-time investment. So 8.137 plus 4 lakhs every year till next 15 years annuity. Second formula has been used, and the FW value we got is 60 lakhs 12,800. 60 lakhs 12,800. Correct? So we are ready with all the three FW values, and we find very easily that A's FW value is greater compared to B and C. So we will have to select A and write your conclusion this way. Since for this revenue based case or alternative, you write if A is maximum, here it is written, don't write that, you write FWA. A is maximum, what does it mean? The future of A is maximum, so write FWA is maximum, A will be selected. Since for this revenue based case, FWA is maximum, A will be selected. Okay, moving to the next. Moving to the next, and before I do that, I must show you the question, because you'll only find solution. So that is that. Let me show you the question. This question. This question. We had used the same question for solving using present oath method, and now we'll solve the same question using future oath method. Let us look at the question first. Alpha, beta are the two machines that are being considered. Initial cost. Initial cost is 6,60,000 and 8,20,000 respectively for alpha and beta. Their annual operational and maintenance cost. Annual operational and maintenance cost is 50,000 and 15,000. And life in years is 20 years. Rate of interest is 18% compounded annually. We have already discussed, just to remind you, this is a cost-based question. This is a cost-dominated question for the simple reason that there is no revenue component in this question. There is no income. There is no earning of the producer or company here. You'll find only the company spending, and that too in two different ways. One is to purchase it initially. The second is to maintain and operate it. And the difference is this 6,60,000 and 8,20,000, these are single time investments. Whereas this 50,000 and 15,000 are recurring expenditure. Annual operational and maintenance cost means this is also expenditure, but of a different nature. In the sense that the company needs to spend 50,000 rupees every year to maintain and operate Alpha for next 20 years. Whereas for Beta, the company needs to spend 15,000 rupees every year to maintain and operate machine Beta for next 20 years. Every year 15,000 for next 20 years. And the rate of interest is 18%. Let us look at the solution. Let us look at the solution. This is the solution. This is the solution. Small things you need to remember here. You see the negative side before C naught, the negative sign before C naught disappears. Reason, this is a purely cost-based case. This is a cost-based case, and in cost-based case, we do not put a negative sign before the C naught value or the initial investment value. Correct. So that is why please keep these small things in mind, else you will commit mistakes. I have found so many cases of that during exams. Right formula you have used and other things, calculations are right, but you have put a negative sign for a cost-based case. So that will be wrong to do. So now look at the solution. 6,60,000 times 1 plus 18% whole to the power 20, and rightly so. First formula has been used because this is a single time expenditure, 6,60,000. So accordingly, the first formula has been used. The normal compound interest formula has been used. But for the second one, you see, it is annual operational maintenance cost. Every year, the company must spend 50,000 rupees for the next 20 years. So you need to find. So you find that this is an annuity problem. And accordingly, you see the second formula has been used, which is 1 plus 18% whole to the power 20 minus 1 whole divided by 18%. Correct. So, and the same thing, if you remember the value for this formula and this formula, you did not do it for beta, you can simply multiply, and that's what exactly you find. The value of 1 plus 18% whole to the power 20 is 27.393. And the same has been multiplied for beta, 8,20,000 times 1 plus r whole to the power t, and its value is 27.393. And since 8,20,000 is single time investment, that is why the first formula has been used. But you know that this 15,000 is annual operational and maintenance cost. The company must spend this for every year till next 20 years. So annuity problem again. And you find that the value for this formula is 146.628. 146.828. Sorry, 628. So, and now once you do that, look at the value. Look at the value. For alpha, it is 25 lakhs. No. 2 crore 54 lakhs 10,780. For alpha, the value is 2 crore 54 lakhs 10,780. Whereas for beta, it is 2 crore 46 lakhs 61,680. And remember, this is a cost-based case, and that is why the Dixon rule we have already discussed. The Dixon rule says the project with the minimum FW amount should be selected. And since we find that FW beta is less than FW alpha, we will have to select beta because it is having the least FW amount between the two. So accordingly, the conclusion, since for this cost-based case, again, do not write beta, write FW beta. Since for this cost-based case, FW beta is minimum, beta will be selected or beta will be purchased. Beta will be selected or beta will be purchased. So, because this is a cost-based question. Okay, so we are left with two more questions. And the next question, you'll find an additional column of salvage value. And I hope you still remember what is the salvage value. Let me show you. Salvage value, we have already discussed this, and we use some questions also to solve involving salvage value. Salvage value is the value that is left over after the asset completes its lifetime. I was giving an example. If you remember, when a machine goes out of order, it cannot be used in production further. What do the owners of those machines they usually do? They usually sell it. They usually sell it to kabadiwala, and in return they get some money, and that money they receive after selling those old outdated assets are called salvage value. And remember one more thing, I have already said these are all repetitions I'm making. Remember, salvage value is the revenue component. It is an earning, it is not an expenditure. The company receives some money in exchange of the old assets. So it is a revenue component. Correct. So, and look at this question. Look at this question. Alpha and beta machines are 3,20,000, sorry, initial cost. IC means initial cost, which is 3,20,000 and 2,10,000 respectively for alpha and beta. Then AOMC means annual operational and maintenance cost. Annual operational and maintenance cost, which is 20,000 for alpha and 5,000 for beta respectively. That means the company must pay 20,000 every year till next 18 years for alpha, and the company must spend 5,000 every year for beta till next 18 years. And as I discussed salvage value, you find this column salvage value, which is 50,000 and 30,000 respectively for alpha and beta. And remember, this is a revenue component. Correct. So now, and rate of interest is 12%. Life is 18 years. Let us look at the solution. Let us look at the solution. This is over. This is over. Look at the solution. Look at the solution. And I forgot to say which based case it is, revenue based or cost based. Let me again show you the question. This question, this is again, the very first thing you need to decide is whether this is a revenue based or cost based case. And we have already discussed, just because we may have forgotten. So that is why I'm saying this is a cost dominated case. Despite a revenue component present in this question, you still find that this is a cost dominated case. Why? Just to reiterate, these two are cost elements, cost components in this question. One is initial cost, that is one-time cost, 3,20,000, 2,10,000. The other one is recurring expenditure. Every year you must be spending this. So these are cost. Only revenue component is this. Only revenue component. And certainly you find cost is C is dominating R. Cost is dominating R. Cost is dominating R. Okay. So this is a cost dominated case. Okay. Now let us look at the solution. Before that, I must delete this. Eraser. Okay. Just a second. Let me. So we can go to the solution page. Now look at the solution. Look at the solution. And one very important thing you must understand here. So please, those who are interested, please focus. First thing you remember, or you already know, that here you are not going to put a negative sign before C not value, because this is a cost dominated case. That is the first thing you need to remember. So there you see there is no negative sign here, and formulas have been used correctly. 3,20,000 single time investment. So first formula has been used, normal compound interest formula, plus 20,000. This is another expenditure, but this is going to be spent every year till next 18 years. So annuity, case of annuity. So accordingly, the second formula has been used. 1 plus 12% whole divided by 18 minus 1 whole divided by 12%. Correct. Now, importantly, very importantly, those who are interested, please focus to understand. Then the salvage value. You see what has been done to salvage value. The salvage value has been deducted, though it is a revenue component. The same we had done in case of present worth method. We had deducted. We had solved the same question using present worth method. And also we had subtracted, for this question, we had subtracted salvage value. So no difference in that. But difference is find with regard to the treatment of salvage value. In present worth method, let me show you so that it will be very clear now. Let me show you again so that you can recall this question. This question, you see what has been done to salvage value. Here, where I put the highlighter. Minus 50,000 divided by 1 plus 12% whole to the power 80. Now, you not only subtracted 50,000, but also divided it by 1 plus 12% whole to the power 80. Now, why had you done that? Because here we were doing present worth method, and by definition, by meaning, salvage value is the value that you receive after the end of the lifetime of a project. So you receive it after 18 years. So that since you were doing present worth method, you wanted to find out the present worth of this 50,000 rupees. That is why you had done this 50,000 divided by 1 plus 12% whole to the power 80. Else your answer would have been wrong. But here you see, you must have understood by now. But here, since just a second. Now here, since this is already the future worth, salvage value, by definition, by nature, it is always the future amount, and we are already doing the future method. So that is why it will be simply minus 50,000. No changes in that. Because at times I find students will divide it by 1 plus r whole to the power t. Even if they are doing future worth method. No, not required. It will give you wrong results. Here the question is simple. The 50,000 rupees that you expect to get as salvage value after 18 years, what is its value after 18 years? The same value, 50,000 rupees. So that is why you did not change anything. Simply do it minus 50,000. Hope you understood. And the value is 35 lakhs 25,800. 35 lakhs 25,800. The value, and beta, you see beta, same way, no negative sign, 2,10,000 single time investment, formula 1 has been used. 5,000 annual operational maintenance cost, every year you must spend this amount till next 18 years. So annuity problem. So second formula has been used. Minus 30,000, simple, only minus 30,000, because This is already in its future note. This 30,000 amount is already in its future note. So that is why no need to change that. And you find it to be 18,63,650. The FW alpha is 35 lakhs 25,800, whereas FW beta is 18 lakhs 63,650. And this is a cost based case. So you find FWB is less than FW alpha. So that is why, right, your conclusion is, since for this cost based case, FW beta is minimum, beta will be selected. Since for the cost based case, FW beta is minimum, beta will be selected. So because this is a cost based case. Last question for the day. Last question for the day. I must show you the question so that just a second. 1 second, 1 second. Hello. Good evening. Can you call me after 10 minutes? Just call me after 10 minutes. Okay, last question. I'll just show you and we can. Last question. This is the question. This question. Machine C and D. First cost or initial cost is 7,50,000 for C and 7 lakhs for D. Then annual revenue 1,50,000 for C and 1,30,000 for D. Every year you expect to get 1,50,000 for next 20 years from C. Every year you expect to get 1,30,000 till next 20 years from D. Salvage value is nil for C, but 80,000 for D, and life in years is 20. Rate of interest is 15% compounded annually. And again, what kind of a question is this? This is a revenue dominated case. Why? Because I have already explained this. Because these two components are revenue components. But only cost component is this. So 1,50,000 20 times is certainly greater than 7,50,000 one time. 1,30,000 20 times plus 80,000 single time is certainly greater than 7 lakhs. So you find this question, in this question, the revenue dominates the cost. And the decision rule says that the project with the maximum FW amount should be selected, because this is a revenue based case. So you can look at the solution. Just look at the solution. I know you must be getting restless. So just 2 more minutes. I'll just show you the solution, then we can wind up. Where is the solution? This one. You see again, the negative sign appears because this is a revenue dominated case. So again the negative sign appears before C naught. So minus 7,50,000 one time investment. So that is why the first formula has been used. Accordingly. So whose value is 16.367. You remember that, so that you can just multiply that for D. And 1,50,000 is annual revenue. It is annual revenue. So that is why for the next 18 years or 20 years. 20 years. So that is why this is another annuity problem. So second formula has been used, you see, and there is no salvage value, so not a problem. But for D there is a salvage value. So there is a salvage value for D. So the value you got for FWC is 3,91,350. 3 lakhs. No. 30 lakhs 91,350. Sorry, 30 lakhs 91,350. D minus 7 lakhs single time investment. So first formula, whose value is 16.367. 1,30,000 is annual return. You expect to get this every year till next 20 years. So second formula, whose value is 102.444. Now there is a mistake here. There is a mistake here. Salvage value will be added here. There is a mistake. This is a big blunder. It will be added. Why? Because these two are revenue components. These two are revenue components, and we must add this up. Then we must subtract this. Then we must subtract this. So this should be plus 80,000, not minus 80,000. I don't know whether this final answer has added 80,000 or has subtracted. If it has subtracted, then this should be wrong. So you check it for yourself, but understand that it will be plus 80,000 because this is a revenue component. And we can see, look at the final answer. Since revenue best case, C is greater than D, so C should be selected. So you find C's value, FW value is greater than D's FW value. So because this is a revenue based case, so C should be selected. Now this concludes your future oath method of project evaluation. Okay, thank you.